Hi, eighth graders. Real quickly, I wanted to go over last night's assignment, number 3. So, number 3 said Melanie collects coins from all over the world. She is reorganizing her collection into coins from Europe and coins from other parts of the world. After sorting the coins, she comes to the conclusion that 6 out of every 10 of the coins in her collection are from Europe. So, I want to underline that part. 6 out of every 10 are from Europe. This is similar to the problem in this lesson of female students to the total students, male students to the total students, where we were writing different ratios, and then we're going to use those ratios. So in part A, it says write a ratio for the number of European coins to the total coins. So European to total. We know 6 out of every 10 are from Europe. So this ratio would be 6 over 10. And we could simplify it. I'm going to just leave it as 6 over 10. So that's the first ratio. Then it says we're supposed to write a ratio for non-European coins to the total. So non-European to the total. Well, if 6 out of 10 are from Europe, that means 4 out of 10 are non-European. And then finally, the number of European coins to the number of non-European coins. So European to non-European. 6 out of the 10 were European. 4 out of the 10 were non-European. So this would be 6 to 4, 6 over 4. Again, I could simplify all those, but I'm just going to leave them the way they are right now so we can see how it relates to the problem. Part B, it says that she has 230 coins in her collection. This is a total. Determine the number of European and non-European coins that she has. So let's think back to our ratios here. European is 6 out of 10. Non-European was 4 out of 10. Let's find the number of European first. So that means I'm going to be using this ratio because I'm finding the number of European and I have the total. This ratio relates European to total. So this is the ratio these coins should be in. So this ratio should equal another ratio when there is 230 coins total. The reason I put it down here is because that's how this ratio is written. This is European to total. So this has to be European to total. I don't know the number of European right now in this case. So I'm going to use a variable, x, and now I have a proportion. So to solve a proportion, I do my cross products. 10 times x is 10x. 230 times 6 is 1,380. These cross products have to be equal. So now I have an equation with my variable that I want to solve for. Divide both sides by 10 to solve for the variable. And you'll find that there are 138 European coins. Now, we could solve a proportion using this ratio for the number of non-European coins, but if I know the number of European coins and I know the total is 230, I can just subtract. So borrow again. That means there are 92 non-European coins. So 138 European, 92 non-European. Part C, it says she's adding to her collection while keeping the same ratio of coins. So her collection is changing, but the ratios are staying the same. So the ratios, again, for European to total, 6 to 10. Non-European is 4 to 10. Now it says she has 180 European coins. So I like to write this stuff down. 180 European. Determine the number of non-European. So we're trying to find number of non-European. And the total number. So we're finding these two things. Let's find non-European first, okay? So let's find this first. We know that she has 180 European coins. We're trying to find the non-European, so we actually need another ratio that compares European to non-European. European to non-European was 6 to 4. So we're going to use that ratio, 6 to 4. That has to equal the ratio with 180 European coins. The 6 represented European, so I'm going to put the 180 in the same spot that the 6 is. This is the spot that I'm trying to find. So 6 times x is 6x. 4 times 180 is 720. When I divide by 6, x is going to equal 120 non-European coins. To find the total number of coins, if I know there's 180 European and I know there's 120 non-European, I can just add those. 180 plus 120 means there's 300 total. Moving on to part D, write an equation to determine the number of European coins, E. So E stands for European coins. If Melanie has T, total coins. Show your work and identify the constant of proportionality. Well, constant of proportionality is the ratio that these European coins are to the total, which we said was 6 to 10. Okay, so write an equation to determine, we know our equation is going to be in this form, y equals kx, where this is our constant of proportionality. So we know that's going to be 6/10. We just need to determine what goes in place of y, what goes in place of x. So x is the independent variable. Y is the dependent variable. In this situation, the European coins depend on the total number of coins. We know 6 out of 10 of the total are European. So European is the dependent. So E is going to go here in place of Y. And T is going to be the independent. So my equation is E equals 6/10 T. For part E, we're writing an equation for the non-European coins. So non-European coins is N. And we're still using T for total coins. Our constant of proportionality in this problem, since we're dealing with non-European, is that ratio of non-European to total, or 4/10. We know our equation is going to look like this, where this is the 4/10. And again, non-European depends on the total. So non-European is the dependent variable like y. So N is going to go here. T is the dependent like x. So T is going to go here, and my equation would be N equals 4/10 T. I'm going to skip part F, the graphing part of this. I just wanted to be clear on how to use the ratios, how to solve proportions, and how to write equations from all of that information. So I hope that helps. Have a great day, everyone.